Algebra 2 students, we are going to be starting into the second half of Chapter 6 today with Lesson 6.5. My plan is to do the first half of the notes or so. I definitely plan to do the first page of notes. I may do an example on the second page, I may not. I'll see how the timing on this video goes. And then next day when I am in class, I will plan to finish the notes with you in class, and that way you can ask questions in person. So that is my plan as of right now. I'm recording this video early, but my plan is that you will watch this video on Friday the 22nd, and so that means the following Monday the 25th is when we would finish these notes. Also means the homework will become available during this period that you're watching this video, and then if I finish the notes with you on Monday the 25th, the homework would not be due until Tuesday the 26th. Okay, we just quizzed about square roots. Well, now we are going to be solving equations that involve square roots and other radicals. So, note right there at the top, an important thing to remember when solving equations where you have to power both sides is to check for extraneous solutions. So just before we continue, just kind of beware that we may have extra solutions sometimes that don't work. Now, that will be more on example 4, which is on the back side, and we'll do that lesson hopefully in person together. Let's start by looking at example 1a here. The equation 3 plus the square root of 2x minus 3 equals 8. And what is our technique when we have just one radical in an equation? In this case, it's a square root. Could be any type of root, but when we have just one square root, what does our technique have to be? And hopefully you realize our technique has to be to isolate the radical first. And I'm even going to write that here in the middle, and I would encourage you to write it as well. But we want to isolate the radical, meaning I'm wanting you to get the radical all by itself. So if we look at example A, it's 3 plus the square root of 2x minus 3. So your first question is, okay, how do I get that square root by itself? There's a 3 being added to the square root, so we're going to want to subtract 3 to move it to the other side. If I subtract 3 on the left, you know I'm going to say to subtract 3 on the right. So now, cleaning up, on the left, 3 minus 3 will cancel, and we are left with the square root of 2x minus 3 equals, on the right we have 8 minus 3, which is 5. Okay, once you have isolated the radical and you've gotten that radical to be by itself, then your job is to get rid of the radical. And in this case, I have a square root, which means it has an index or a root of 2. So what's going to undo a square root? And that's going to be raising it to the power of 2. If it was a cube root, you'd raise it to the power of 3, so on and so forth. Now, if you raise the left side to the power of 2, that means we have to raise the right side to the power of 2. So, follow along with me as we clean this up. On the left, when you square a square root, this goes back to the whole idea square root of smiley face times square root of smiley face equals smiley face. So square root of 2x minus 3 times square root of 2x minus 3 is going to equal 2x minus 3. When you square a square root, you get whatever's under the radical. On the right, we have 5, and we're squaring it, and 5 squared is 25. Now at this point, you have a basic two-step equation that I have hopes we know how to solve. If it's 2x minus 3, we're going to add 3 to both sides. The minus 3 plus 3 will cancel. I have 2x equals, and 25 plus 3 is 28. Then to get x by itself, if it's 2 times x, we're going to divide by 2. If we divide the left by 2, we're going to divide the right by 2. And 2x divided by 2 becomes x. 28 divided by 2 becomes 14. And you have solved your first square root equation, or radical equation. So, isolate the radical, and then to remove the radical, you raise it to whatever power that the index is. Let's try b. b is the square root of 4x plus 1 minus 5 equals 0. So your first question is my radical by itself. So we have the square root of 4x plus 1, but then we also have that minus 5. To get rid of minus 5, we should add 5. If I add 5 on the left, I'm going to add 5 on the right. So clean it up. I still have the square root of 4x plus 1 minus 5 plus 5 cancels equals 0 plus 5, which is 5. Is my square root by itself? And indeed it is. It's just 4x plus 1 under it. So in order to get rid of a square root, again, it has an index of 2. It's a square root, so we're going to raise it to the power of 2. If we raise the left to the power of 2, we raise the right to the power of 2. So, again, I ask, what happens when we square a square root? So we take the square root of 4x plus 1 and we square it. We're going to get whatever's under the radical, which is 4x plus 1. On the right, 5 squared. 5 times 5 is 25. And now you have an equation that you can solve for x. If it's 4x plus 1, how do I get x by itself? First step is to subtract 1. If I subtract 1 on the left, I subtract 1 on the right. So the 1 minus 1 cancels. I'm left with 4x equals 25 minus 1 is 24. If it's 4 times x, we're going to divide by 4. And 4x divided by 4 leaves me with x. 24 divided by 4 leaves me with 6. And so we have x equals 6. Okay. So finish up example B there. And then we can get ready to look at example 2. You'll notice example 2 says solving other radical equations. As you kind of skim, you'll notice some of them still have radicals in them, like B and D. And some of them, like A and C, do not have radicals, but they have exponents that are fractions. So, even though our steps are still going to be the same, if there is one radical or one set of parentheses that has a fraction exponent, our job is to isolate it, and then we'll go from there. So as we look at example A, it's 3 times x plus 1 to the 2/3. So my first question is, how do I get the x plus 1 to the 2/3 by itself? And notice it's 3 times that amount. So to move a times 3, we're going to divide by 3. If I divide the left side of the equation by 3, we have to divide the right side of the equation by 3. The 3's will cancel. And so we're going to have x plus 1 raised to the 2/3 power on the left. And on the right, 12 divided by 3 is going to equal 4. Now, there are a couple of different ways we can do this from here. I'm going to teach you a way that just involves using the exponent. However, if you're more comfortable, you could change it into a radical, and I could go over that with you in person sometime if you would prefer, or even individually. But at this point, as I look at my exponent, I have an exponent of 2/3. And I need that exponent of 2/3 to cancel out. So we're going to raise to another exponent. And if I want my 2/3 to cancel out to be a 1, I'm going to raise to the reciprocal power, which means I'm going to take this 2/3 power and I'm going to raise it to the power of 3/2. So since it was 2/3, I picked 3/2. Now, if I raise the left side of the equation to the 3/2 power, then I need to do the same thing for the right side. Okay, so I use the reciprocal power there. Now it's all about a bunch of cleanup. On the left, remember when you raise a power to a power, you multiply. Well, the whole reason of me using the reciprocal is when I multiply 2/3 times 3/2, I get 6/6, which is 1. And a power of 1, I don't have to write. So that means on the left side, those powers will cancel each other out, and I just have x plus 1. On the right, I have 4 to the 3/2. Now, we're going to go back and use our lesson 6-4 skills and talk about what does 4 to the 3/2 mean. And in this case, I'm going to put my 4 under the radical. We're going to think about it in radical terms because your brains will work a little bit better there. My brain works better there. So 3/2. That means what kind of root? Well, the denominator of 2 determines my root, so it's a square root. And the 3 in the numerator is the power. So this is raised to a power of 3. Now, notice, we essentially took the square root of both sides. And there's a catch here. If you recall, when we take the square root of both sides in an equation, you have to include a plus or minus. And so the little note I'm going to put here is if the denominator, so in this case the 2, the denominator, or index is even, use plus or minus. So that is a little side note you'll want to keep into play. It's just like, if you recall, when we take the square root of both sides, we always include a plus or minus to account for the positive and negative solutions. So in this case, it didn't look like we were taking the square root, but a denominator of 2 is the same as a square root. And I will keep reminding you of that. Okay. On the left, x plus 1 is still x plus 1. On the right, I still have the plus or minus, and then you have to figure out the square root of 4 raised to the power of 3. And you can do those steps in either way. So to me, the square root of 4 is 2. And then what's 2 raised to the power of 3? Well, 2 times 2 is 4, times 2 is 8. If you would prefer, the other option you could have done is you could have done 4 to the 3rd, which 4 times 4 is 16, times 4 is 64, and then the square root of 64 is 8. So it works the same as in both ways. Okay. How do I finish solving this? If it's x plus 1, we're going to have to subtract 1. Now, keep in mind, what is I'm going to be subtracting 1 from? And hopefully you realize there are technically 2 equations to solve here. I'm going to be solving the equation x plus 1 equals positive 8, and x plus 1 equals negative 8. So we're going to have 2 possible solutions. In both cases, though, if it's x plus 1, you know to subtract 1 to find the solution. And so when I do that, on the first one, 8 minus 1 is going to give me a solution of 7. Or, in my second equation, it's going to be negative 8 minus 1, which is going to give me a solution of negative 9. So we have 2 possible solutions, 7 and negative 9. And they would both make this equation true because the original problem was a cube root. So we could have a positive or negative option there. Okay? Okay, that problem was a little bit different. I get it. It was probably a little tough for us to be doing via video without face-to-face, but it's kind of the way things are today. When we get down to C, we'll try another one with an exponent and go from there. In the meantime, let's try looking at B. Notice B, like the top ones, has a radical. The only difference is it's not a square root, it's a fifth root. Just like up above, my first step was to isolate the radical. My first step again is to isolate the radical. So if I currently have 3 times this radical plus 1 equals 25. 3 times something plus 1 equals 25. First step to gain that radical by itself is to subtract 1. If we subtract 1 on the left, we subtract 1 on the right. So I'm going to have 3 times this radical, which is the fifth root of x plus 1 to the third. The 1's will cancel, and 25 minus 1 is 24. Is my radical by itself? And the answer is not quite. It's 3 times the radical. So to get rid of 3 times the radical, we're going to divide by 3. If I divide the left by 3, we divide the right by 3. The 3's will cancel. The fifth root of x plus 1 to the third equals, and 24 divided by 3 is 8. Okay. Now, do we have the radical isolated by itself? And of course, the answer is yes, the radical is by itself. So, to get the radical by itself, to continue now the radicals by itself, we have to get rid of that radical. That radical is a fifth root. To get rid of a fifth root, we're going to raise this equation to what power? And we're going to raise it to the power of 5. If I raise the left to the power of 5, I raise the right to the power of 5. So, on the left, the fifth root raised to the fifth leaves us with whatever's under the radical, which is x plus 1 raised to the third. On the right, we have 8 to the fifth. We have 2 options here. You can, if you want, go ahead and figure out what 8 to the fifth is. That's a calculator problem in my brain. I don't know what it is. I honestly am just going to leave it as 8 to the fifth, and I'll show you why in the next step. Okay. We now have x plus 1 to the third. My goal is to get x by itself, but I have this third power. How can we get rid of a third power? Something to the third, the opposite of it is going to take the cube root. So since it's something to the third, we're going to take the cube root. If I take the cube root of the left, we're going to take the cube root of the right. On the left, x plus 1 to the third, the cube root of it, those 3's cancel each other out, and I am just left with x plus 1. On the right, I have the cube root of 8 to the fifth. Now, you have options again. You can use the calculator. You have that big 8 to the fifth number, and then cube root it. Or, if you don't happen to have a calculator accessible, this is doable without a calculator. Remember, when we have powers and roots, we can do either order. So instead of doing 8 to the fifth, can you tell me the cube root of 8? And the cube root of 8 is going to be 2. And then you're doing 2 to the fifth. And 2 to the fifth is one that I hope you're becoming familiar with, is 32. You will notice I did not put a plus or minus in front of this 32 because we didn't take an even root. We took a cube root, and so you don't use plus or minus. Okay, pause the video at any point if you need to absorb something or repeat it. Final step, if it's x plus 1, how do I get x by itself? And that is going to be to subtract 1. If we subtract 1 on the left, we subtract 1 on the right, and we get a final answer of x equals 31. Moving on to C. As we look at C, you will notice it's a lot like A, in that there is a power that is a fraction exponent, a rational exponent. So whether it's the parentheses with the exponent or the radical, it's still getting that piece by itself. So in order to get it by itself, notice there's 2 times the parentheses out front, so we're going to undo the 2 times the parentheses and divide by 2. If I divide the left by 2, I divide the right by 2. So the 2's cancel. I'm going to have x plus 3 to the 2/3 power equals 8 divided by 2 is 4. Okay, notice I have a parentheses raised to a power. Those parentheses are by themselves, so that's good. How do we get rid of that power? Look up to example A. How did we get rid of a 2/3 power? We raised it to the reciprocal. What is the reciprocal of 2/3? And that reciprocal of 2/3 is 3/2. If I raise the left to 3/2, we raise the right to the 3/2 power. On the left, the 2/3 times 3/2 will cancel each other out, and I am left with x plus 3. On the right, 4 to the 3/2. Well, before we forget, what do you notice about that denominator? It's a denominator of 2, which is even. Actually, here, let me write this out. If I write this instead of fraction, but as a radical, it's what kind of root and what kind of power. Well, the denominator of 2 says it's a square root. The power of 3, or the numerator of 3, says it's a power of 3. Do I need a plus or minus there? And the answer is yes, because it was an even root, a square root. Okay. On the left, it's still x plus 3 for right now. On the right, clean it up. It's the square root of 4 raised to the 3rd, or you can do that the other way. The square root of 4 is 2, and 2 to the 3rd is 8. So this is going to be plus or minus 8. And you'll notice it is working similar to example A. Now, if you can solve it like that, and you can finish it up and get your 2 answers, that's great. Otherwise, feel free to split this into 2 equations. An equation that says x plus 3 equals positive 8, and an equation that says x plus 3 equals negative 8. If it's x plus 3, how do we solve it? If it's x plus 3, we're going to subtract 3. So if we subtract 3, and the first one, 8 minus 3 is going to give me an answer of 5. And on the other one, negative 8 minus 3 is going to give me an answer of negative 11. So I have answers of 5 and negative 11. And again, we won't worry about checking for extraneous solutions until we get multiple x's in the problem like back in example 4. Okay? Or problems where we have to multiple times square the problem. Those type of things. Okay. Let's try D. D is the first one of its kind in that what's different about D? And you will notice it has not 1, but 2 radicals. So our plan has to change a little bit. When there's just 1 radical, your job is to isolate the radical, get it by itself. When there are 2 radicals, your plan has to become, we have to separate those. Now, this will be an easy example because we'll separate them and it'll all work out nicely. If there are other terms, it becomes a little more complicated. Now, in this case, if I have 2 radicals being subtracted, how can I take one of those radicals and move it to the other side? And the key will be, how can I move a minus square root of 3x and to move something that's being subtracted, you're going to add it. If you add square root of 3x on the left, that means you have to add square root of 3x on the right. So let's look and see what this cleans up. On the left, we're still going to have square root of 4x minus 2. On the right, or then the minus square root of 3x plus square root of 3x cancel. On the right, it's 0 plus square root of 3x, which is just square root of 3x. How do I get rid of the square root? And again, you raise it to the power of 2. Since it's an index of 2, we're going to square it. If we square the left, we square the right. So what happens when we square the square root? You square the square root of 4x minus 2, you're going to get 4x minus 2. On the right, when you square the square root of 3x, you're just going to get 3x. And now the nice part is we have a nice equation where my variables disappeared. Your job is to get your variables or letters on the same side, numbers on the other side. Now, there's a couple different ways we can do this. If I already have a 3x by itself on the right, are you okay with me moving that positive 4x over to the right to join it? How would I move a positive 4x? A positive 4x, you would have to subtract 4x. If I subtract 4x on the left, 4x minus 4x is canceled, and I'm left with negative 2. On the right, if you subtract 4x, 3x minus 4x is negative 1x or negative x. Okay, I want it to read x equals. It currently reads negative x equals. How do I get rid of the negative? And one option is, yes, is divide by negative 1. The other option, if you prefer, is to multiply by negative 1. So what is negative 2 divided by negative 1? That's positive 2. Negative x divided by negative 1 is positive x. So we end up with a solution of x equals positive 2. Okay. Now, where am I at? I'm at about 28 minutes on this recording. I think, let's go ahead and look at the word problem on the next page real quick, and then I'll call it quits. So turn to your next page. We're going to look at example 3. For meteor crater in Arizona, the formula D equals 2 times the cube root of V over 0.3. You know what I'm going to say I love about this problem. They just gave me a formula. It relates the diameter of the rim in meters to the volume in cubic meters. They're asking me what is the volume of meteor crater given that the diameter is 1.2 kilometers. Remember that there are 1,000 meters in 1 kilometer. So hold that thought. Okay, and I think the one other thing the reason they gave that important piece of information, the diameter is 1.2 kilometers. Go back and read in the previous sentence. The diameter of the rim is in terms of meters. So that's going to be the catch right there, is that the diameter is given in terms of meters. Okay, so first thing I'm going to do, I'm going to write my formula down. My formula that we're going to be using, D equals 2 times the cube root of V over 0.3. Okay, so job, of course, is to fill in what you can. Were we given a D? And yes, we were given a D. We were given a diameter of 1.2 kilometers. Now, read the problem. The diameter of the rim is in meters for this equation. So, okay, Information's given, 1,000 meters in 1 kilometer. So if we're talking about 1.2 kilometers, 1,000 meters for the 1 kilometer. So, and then 200 more for the 0.2, 1,200 meters. Or if you're a decimal moving person, move the decimal 3 places to the right. So in for D, I'm going to put 1,200 because we're working in meters. It's still 2 times the cube root of V over 0.3. My job is to solve for V. So of course, it's all about solving this equation. Like the front side, how do we get the radical by itself? And first off, you should notice that it's 2 times the radical. So to move that 2, we're going to divide by 2. If I divide one side by 2, we're dividing the other side by 2. 1,200 divided by 2 is going to be 600. On the other side, the 2's cancel, and so I have the cube root of V over 0.3. Now is my radical isolated. And yes, it's just the cube root. So how do we get rid of a cube root? If it's a cube root, we're going to have to raise it to the power of 3. If we raise one side to the power of 3, we're raising the other side to the power of 3. So, 600 to the third. I will worry about that in my final answer. I'm just going to write it as 600 to the third for the moment. On the right, when I cube a cube root, what happens? Those 3's cancel and I have V divided by 0.3. Okay, one last step, solving for V. If it's V divided by 0.3, we need to multiply by 0.3. If you multiply one side by 0.3, you multiply the other side by 0.3. So 0.3's will cancel. I'm going to have V equals 0.3 times 600 to the third. And this is where I would definitely go for a calculator and figure it out from there. And I have written down 64,800,000, and this is volume, which if you look back in the original problem, it says volume is in cubic meters, so meters cubed. Okay, that is where I'm stopping for today. We're at be about 34 minutes when I finish here. Any extra time, please feel free to go in and start looking at lesson 6.5. I have confidence that the easy problems are doable right now, and when I am in class, we can work on figuring out some of the kinks and work on figuring out some more of these notes. If all goes well, this is Friday the 22nd I left this, and I think I already talked at the beginning that we'll go over the rest of the notes Monday the 25th, and homework will be due Tuesday the 26th. Good luck, and we will talk again soon.